Good morning, students. Chapter 8, Electromagnetic Waves. Yes. Next topic of this chapter, and yes, one of the most important question of this chapter is characteristics of electromagnetic waves. Yes, electromagnetic waves. How electromagnetic waves are produced? Okay, that we have seen in last lecture. Okay. Yes. Electric field vectors, magnetic field vectors, they are perpendicular to each other, and they both are also perpendicular to direction of propagation. So yes, electric field, magnetic field, and direction of propagation, wave propagation, they are mutually perpendicular to each other. Okay, and yes, it is transverse nature of light. Yes. Now, some characteristics you have to remember for this case. First one is representation in form of equations. Yes, wave in 11th we have discussed. Okay, a wave equation means displacement of any particle at a distance x at time t. How to represent? And yes, we know that y is equal to a sine omega t plus or minus kx plus phi. Y is equal to it is a sine omega t plus or minus kx plus phi, where this y is displacement at time t at distance x, a is amplitude means maximum displacement, omega angular frequency, k wave vector, and phi that is initial phase. Phi is initial phase. Okay. Yes. Plus or minus, when wave propagates in decreasing value of x, in decreasing value of x we have to write plus, and whenever it is propagating in increasing value of x, you have to write it is minus. Okay, so yes, here as electromagnetic waves are propagating in x direction means value of x increases. So I can write E is equal to E0 sine omega t minus kx. Initial phase we have assumed 0. Why j correct? Because see, it is clear that these electric field vectors, okay, they are oscillating in y plane only. They are oscillating in y plane only. Okay, initially it is in plus y direction, then minus y, plus y, minus y. Clear about this? Okay, so see, from this it is clear. Okay, in one electromagnetic wave, electric field vectors, they are only in one plane. They are only in one plane. Clear about this? Okay. Similarly, magnetic field vectors. See, magnetic field vectors, they are parallel to z-axis. So how to write? V is equal to V0 sine omega t minus kx k caret. Where what is E0? E0 is amplitude of electric field. V0 is amplitude of magnetic field. Clear about this two terms? Okay. Omega, angular frequency, and you know that omega is equal to it is 2 pi f. Yes, omega is equal to it is 2 pi f. What is k? K is wave vector, and it is 2 pi upon lambda. And it is 2 pi upon lambda. Another thing, see, in waves and oscillations, you have studied k, omega upon k, it is called speed. Omega upon k, it is called speed. So yes, it is c. C means it is speed of electromagnetic waves in vacuum or in free space. Clear? So first point to remember is representation in form of equations. You have to draw this figure and then you have to write these two equations. Clear about this? Okay. Second point, E upon V is equal to C. E upon V is equal to C. Yes, E0 upon V0 is equal to C. Now, how do we have to accept this equation directly, or we have to prove? We have already proved this equation in chapter number 4 in theory velocity selector. Yes, in theory velocity selector. Okay, when you are given electric and magnetic field perpendicular to each other, cross fields, then yes, in these cross fields only electromagnetic waves or only particles will move without deflection, having speed v is equal to E upon V. Remember? Okay. Yes, again, when you are given cross fields, electric field and magnetic field, then only particles having speed equal to E0 upon T0, they will move without deflection. They will move without deflection. So yes, we have already proved this relation. That is E0 upon D0 is equal to C. That is the speed of electromagnetic waves in vacuum. Okay, so electromagnetic waves are self-sustaining oscillations of electric and magnetic field in free space or vacuum. Clear about this? So yes, this second point we have already proved. Okay, next one. The velocity of electromagnetic wave in free space, C is equal to 1 upon mu 0 epsilon 0. Again, this topic we have discussed in chapter number 4 after Biot-Savart's law in similarities between Coulomb's law and Biot-Savart's law. Last point. Okay, on how to prove this statement. Simple. Epsilon 0 and mu 0. Multiply them, put their value, you will get. Okay, its answer. It is C square. Okay, so yes, you will get its answer 1 upon C square. So yes, this equation we have already proved. Okay, so yes, C is equal to it is 1 upon under root mu 0 epsilon 0. Mu 0 permeability of free space, epsilon 0 permittivity of free space. So yes, the velocity of electromagnetic wave in free space. Now, if such electromagnetic waves, while they are propagating in medium, so simple, we have to replace this epsilon 0 by epsilon. We have to replace this epsilon 0 by epsilon and mu 0 by mu. So the velocity of electromagnetic waves in medium, V is equal to 1 upon under root mu epsilon. Clear about this? Now remember ray optics, you know that how to define refractive index of given medium. Refractive index of given medium theta is equal to C upon E. So if you take ratio of these two equations, under root mu epsilon upon mu 0 epsilon 0, mu upon mu 0, permeability of medium divided by permeability of free space is equal to relative permeability of medium. Similarly, epsilon upon epsilon 0, relative permittivity of medium. And you can also represent this as K, that is dielectric constant. This K is dielectric constant. This K is dielectric constant. Clear? So yes, you have to remember this each and every equations. Okay? So yes, we have completed 3 points. Next point, point number 4. Point number 4. Electromagnetic waves are transverse waves. See, as shown in figure, it is clear. Yes, we have one figure. See, here it is. Electromagnetic waves are transverse waves. Electromagnetic waves are transverse waves. So yes, this point you have to remember. Next, number 5. Electromagnetic waves, they possess energy, and as they propagate, they carry energy with them. Simple. Electromagnetic waves, they possess energy, and they can carry energy from one place to another place. Yes, simple. Okay, from sun on earth we get energy due to electromagnetic waves. Okay, the electromagnetic waves radiation is produced from sun, and that energy is reaching towards earth. Yes, and we can feel it. So yes, this statement, this point we easily understand. Next one. Electromagnetic waves exert pressure on a surface when they are incident on it, called radiation pressure. This imparts linear momentum to the surface. Why? How linear momentum? See, whenever energy is incident on any surface, suppose delta U energy is incident in delta T time on area A, then yes, energy is incident means it exerts some force. Remember KTG, kinetic theory of gases. Whenever particles collide with wall, they exert some pressure on wall. So similarly, here surface, on surface, some pressure is created. Okay, and due to that it gets some momentum. So momentum delivered to surface, delta P is equal to this delta U upon C for complete absorption. Complete absorption means whatever incident energy is completely absorbed by surface. Clear? So yes, there are 5 points, 6 points. Now again, there are some points that we will discuss, but these are 6 points related to characteristics of electromagnetic waves. See, some points are very easy. First of all, how to write equations? Easy. This relation, easy. This relation, easy. Electromagnetic waves are transverse waves. 1 point. It it is considered as 1 point. Okay, so yes, these are 6 points. Next points we will discuss. Next point is the electromagnetic energy per unit volume, that is energy density. Yes, in case of capacitor, energy is stored in form of electric field and its energy density we know, that is half epsilon 0 square amperes. In the case of inductor, energy is stored in the form of magnetic field and we also know its energy density, that is B square upon 2 mu 0. Yes, we know it. So in case of electromagnetic waves, as two regions are, in region there are two fields. In region there are two fields. What is the electromagnetic energy per unit volume? Rho is equal to, it is rho E plus rho B. It is energy density of electric field. It is energy density of magnetic field. So yes, I can write this equation as rho E is half epsilon 0 E square RMS plus rho B means it is B square RMS upon 2 mu 0. Now, why to write E square RMS and B square RMS? E RMS and B RMS why? Because here electromagnetic waves, they are function of sine or cosine, and sine and cosine, they are harmonic functions, means they continuously vary with time. So yes, its average will be 0. So we have to consider their RMS value. We have to consider their RMS value. Okay. So yes, it is half epsilon 2 square RMS plus B square RMS upon 2 mu 0. Now we know that. See, one relation which is C is equal to 1 upon under root mu 0 epsilon 0. So C square is equal to 1 upon mu 0 epsilon 0. Okay? Okay. So mu 0 is equal to 1 upon C square epsilon 0. Simple? Yes or no? Yes, it is. Second relation, E RMS upon V RMS is equal to C. So therefore, V RMS is equal to E RMS upon C. So now this put mu 0 here and this V RMS here. Okay, so yes, we will get it is half epsilon 0 E square RMS plus B square RMS means it is B square RMS upon C square divided by 2. Mu 0 means this one. Yes, mu 0 means this one. Okay, it is 1 upon C square epsilon 0. So this is C square that epsilon 0 I can write in numerical. So it is half epsilon 0 E square RMS plus epsilon 0 in numerical. So I can write it as half epsilon 0 E square RMS. Okay, so is equal to it's half and half equal to full. So it is epsilon 0 E square RMS. It is equation of energy density. Yes, it is equation of energy density. You can also write this equation as rho is equal to B square RMS upon mu 0. In terms of, it is in terms of electric field and it is in terms of magnetic field. So yes, it is one different point. Okay, that yes, you have to obtain this relation, and yes, there are some questions based on this equation. Okay, what is energy density? Okay, clear? Yes, you can also derive this relation. In similar way. Yes, from here you have to make epsilon 0 subject, and from here E RMS. And if now you put equations values here, you will get this equation. So it is one easy point in which you have to obtain this equation. Next point is number 8. That is, the intensity of radiation is defined as the radiant energy per unit area per unit time. It means the incident energy. Suppose we have some object, energy is incident on it. Okay, so the intensity of radiation is defined as the radiant energy passing through unit area normal to direction of propagation in 1 second. and it is I is equal to it is rho c. Okay, and its equation is epsilon 0 c e square RMS, or it is c b square RMS upon mu square. Clear about this? Okay, so yes, it is another equations of intensity that you have to remember. Last point, that is E cross B gives direction of propagation of electromagnetic waves, and yes, we know it. Direction of propagation is in direction of E cross B. So yes, total 9 characteristics of electromagnetic waves, and you have to remember each and every characteristics. Clear about this? Now it depends on the question, how many characteristics you have to write. How many characteristics you have to write. In question of 2 marks and in question of 3 marks, you have to write how many quantities. Okay, so yes, electromagnetic waves, the characteristics, this is it.